Hello everyone, this is Ma'am Amano, and this lecture video is all about the understanding of the general and standard equations of an ellipse. We will be discussing as well the transformation of the equations of an ellipse from general form to standard form. So just like the other coding sections, the equation of an ellipse can also be expressed and written in general and standard form. For general form, we're in the A, B, C, and D, and E are constants. This is the equation. For number 1, we have here the general equation of the ellipse when the center is at the origin. So this is ax squared plus by squared minus c equals 0. For number 2, this is the general form or general equation of an ellipse with center at h and k or at x and y. And then that is ax squared plus by squared plus cx plus dy plus e equals 0. The standard form happens when the h and k are the coordinates of the center, and the a squared refers to the square of the vertices, and b squared refers to the square of the co-vertices. This is the a squared, this is the b squared. The a squared here refers to the end point of the major axis, which is the vertex, and then the b squared refers to the end point of the minor axis, which is the co-vertex. So this is the standard equations of ellipse with center at the origin. This is for horizontal ellipse, and this is for vertical ellipse. Now here is the equation for ellipse with center at h and k or at x and y. This is for the horizontal ellipse, and this is the vertical ellipse. Again, this is the standard form. Now let us have the transformation of the equations of an ellipse from general form to standard form. For case 1, when the center of the ellipse is at the origin, this is the first example. Write the equation 4x squared plus 9y squared minus 36 equals 0 in standard form. So the step 1 is you have to move the constant term to the right side of the equation. That is, if you will move this constant term to the right side of the equation, it will become positive instead of negative. So the new equation for step 1 is 4x squared plus 9y squared equals 36. For step 2, you have to divide the whole equation by the constant term. So the constant term is 36, dividing that into 1 over 36 such that you will be able to place the coefficients at the denominator in order to transform that into standard form. And then that is 36 divided by 36, that is 1. 36 divided by 4, that is 9. Retain the x squared or the variable at the numerator, plus 36 divided by 9, that is 4. Retain the y squared at the numerator, and the final answer would be x squared over 9 plus y squared over 4 equals 1. Another example for the case 1, wherein the center of the ellipse is at the origin, is this one. Example 2, write the equation 11x squared plus 13y squared minus 143 equals 0 in standard form. For step 1, again, you have to move the constant term to the right side of the equation. And then, moving that to the right side of the equation, you will have 11x squared plus 13y squared equals 143. Changing this sign into the positive. And then step 2, you have to divide the whole equation by the constant term, which is 143, 1 over 143, in such that you will be able to place the coefficient at the denominator so that you will be able to transform that into standard form. So 143 divided by 143, that is 1. 143 divided by 11, that is 13. Retain the x squared at the numerator, plus 143 divided by 13, that is 11. Retain the y squared at the numerator, and then you will have the final answer of x squared over 13 plus y squared over 11 equals 1. Then another example for case 1, wherein the center of the ellipse is at the origin. Example 3, write the equation 9x squared plus 25y squared minus 225 equals 0 in standard form. Step 1, again, you have to move the constant term. This is the constant term, the value or the numerical magnitude that do not have the variable. Moving that to the right side of the equation will change the sign into positive. So that will be 9x squared plus 25y squared equals 225. And then step 2, divide the whole equation by the constant term, which is 1 over 225. So 225 divided by 9 is 25, and then put the x squared at the numerator, plus 225 divided by 25, that is 9. Put the y squared at the numerator, and then 225 divided by 225, that is 1. Therefore, the final answer is x squared over 25 plus y squared over 9 equals 1. Now, for case 2, when the center of the ellipse is at h and k or at the x, denoted by h, and y axis. So, the example 1 is write the equation 3x squared plus 2y squared minus 6x minus 12y plus 15 equals 0 in standard form. For step 1, you have to move the constant term to the right side of the equation. Moving that to the right side of the equation, you will have a negative 15 here. This is the new equation 3x squared plus 2y squared minus 6x minus 12y equals negative 15. Step 2, you have to group the terms with the same variables. So, that is 3x squared minus 6x, same letters here. 2y squared plus 2y squared minus 12y here, and then equals negative 15. For step 3, you have to extract the common factor from each group. Here, the common factor that we have here is 3. such that you will be able to know that is correct. If you multiply that here, you will have the same answer as well. So 3 times x squared is 3x squared. 3 times negative 2x, that is negative 6x. So the common factor for this group is 3. And then plus the common factor on the y group is 2. Such that if you multiply that, you will be able to obtain the same value here. So that is 2 times y squared is 2y squared. 2 times negative 6y, that is negative 12y. And then equals to negative 15. Step 4, you have to create two perfect square trinomials by completing the squares. To keep the statement true, you have to observe that the product of the common factor and last term of the trinomial is added to the right side of the equation. So you must convert the terms here inside the parentheses into perfect square trinomials. To convert it into perfect square trinomials, you just have to get the half of that. The half of this one of the first degree is 1, right? 2 divided by 1 is 1, and then square that 1. 1 squared is 1. So you have to add that here on the trinomial. Because when we say trinomial, there are 3 monomials. So you have to add that here. So that is 1, 2, 3. You have here now the trinomials. And then on this part here, to make this into a perfect square trinomial, get the half of this first degree here. The half of 6 is 3. Then 3 squared is 9. 3 squared is 9, then add that here on the last term. So that will be now a perfect square trinomial. Whatever you added here, you must as well add here to keep the statement true. So you will add here on the right side of the equation the common factor of the x and then the last term of the trinomial, which is 1 multiplied to that. So that will be plus 3 times 1. And then plus the common factor of y, which is 2. And then multiply to the last term of the trinomial, which is 9. Step 5, you have to simplify both sides of the equation. To simplify the both sides of the equation, that is 3 times 1 plus 3, 2 times 9 plus 18, then that will be 6 if you will perform the operation here. And then step 6, you have to express the perfect square trinomials as square of binomials. So to convert this perfect square trinomials into square of binomials, you just have to get the first degree of the x squared, and that is x minus because you have a two different signs here, so that will be minus. And then if the last term is 1, not more than 1, you just have to copy that. So that is 1, then squared. And then to get the square of binomial here in the perfect square trinomial, in this case, you just have to get the first degree of this, which is y. Then we have here a different sign, so that is minus. And then get the square root of 9 of the last term, which is 3. Square root of 9 is 3. Then that will be 3. So this is the new equation that we have right now. Now for step 7, you have to divide both sides of the equation by the constant term. And the constant term is 6. And then you will be able to divide that. 6 divided by 6, that is 1 here. 6 divided by 3, that is 2. You will have to put that on the denominator since that is division. And such that you will be able to convert that into standard form. And then retain the x minus 1 squared at the numerator or the binomial. And then 6 divided by 2, that is 3. And then retain the square of binomial at the numerator. So the final answer is x minus 1 squared over 2 plus y minus 3 squared over 3 equals 1. Another example for case 2, when the center of the ellipse is at h and k, you will have here the example to write the equation 7x squared plus 10y squared minus 56x plus 100y plus 292 equals 0 in standard form. So step 1 again is to move the constant term. This is the constant term, the one that do not have a variable, to the right side of the equation. Moving this one will change the sign into a negative sign. So this is the new equation here that we have. For step 2, you have to group the terms with the same variable. So 7x squared minus 56x plus 10y squared plus 100y equals negative 292. And then step 3, you have to extract the common factor for each group. Here on the x group, the common factor is 7. That is 7 because if you will multiply that, you will be able to obtain this answer. 7 times x squared, that is 7x squared. You have to factor out. And then 7 times 8x, that is negative 56x here. Then for this y group, the common factor is 10. If you multiply that here, 10 times y squared, you will have 10y squared plus 10 times 10y, that will be 100y. Okay, so this is the new equation that we have for step 3. For step 4, you have to create two perfect square trinomials from x and y by completing the squares. So to make a perfect square trinomial, you have to get the half of 8 here, of this first degree variable here. You have to get the half of that, and that is 4. And then that is 4, then square the 4, that will be 4 times 4, that will be 16, square that. So plus 16 here on the last term. So you now have the trinomials because you have now here the three monomials. Plus make this one a perfect square by getting the half of the 10. Why? Okay, you always get the half of the first degree. So half of the 10 is 5, and 5 squared is 25. So you will add the 25 at the last term of this one. you will now have the trinomial or perfect square trinomial here. So whatever you added here, you will also add on the left side of the equation. So that is negative 292 plus the common factor of x, which is 7, multiplied to the 16, the last term of the trinomial, and then plus 10, the common factor of the y group, and then multiplied to the 25 or to the last term of the trinomial, that is 25 here. Then step 5, you have to simplify the equation, that is 7 times 16 equals plus 212, 10 times 25 is plus 250, then perform the operation, negative 292 plus 112 plus 250, that is 70. This is the new equation. Then for step 6, you have to convert the perfect square trinomials into the square of binomial. So to convert this into square of binomials, you have to get the first degree of the x squared, that is x, minus get the square root of the 16, that is 4, and then square that. So you will now have the perfect square binomial of x minus 4 squared. Plus here, to get the square of binomials here, you have to get the first degree of the y squared, and that is y. Since all of these are positive signs, that is plus, and then get the square root of 25, that is 5, then square that term. And then this is the new equation. So for step 7, you have to divide the whole equation by its constant term, which is 70. So 70 divided by 7, that is 10 at the denominator, and then retain the x minus 4 squared at the numerator, plus 70 divided by 10, that is 7, and then the square of the binomial at the numerator. 70 divided by 70, that is 1. Therefore, the final answer is x minus 4 squared over 10 plus y plus 5 squared over 7 equals 1. Another example for case 2, wherein the center of the ellipse is at x and y, or at HK. Example 3, write the equation x squared plus 4y squared plus 2x plus 32y plus 61 equals 0 in standard form. Step 1, again, you have to move the constant term to the right side of the equation. That will be negative 61. This is the new equation. For step 2, you have to group the terms with the same variables. That is x squared here plus 2x plus 4y squared plus 32y. For step 3, you have to extract the common factor from each group. For x group, the common factor is 1. If you will multiply that here, 1 times x squared, that is x squared. 1 times 2x, that is 2x. For the y group, the common factor is 4. If you will multiply this one, you will have the same answer as this one. 4 times y squared, that is 4y squared. 4 times 8y, that is 32y. This is the new equation that we have here. For step 4, you have to convert the terms inside the parentheses into perfect square trinomials. To convert it into perfect square trinomials, you have to get the half of the first degree variables here. The half of 2 is 1, and then square that 1. 1 raised to 2, that is plus 1 here. And then on this group, half of 8 is 4. And then square the 4, that is 16, plus 16 here on the last term. So whatever you added here, you will also add here on the side. So that is negative 61 plus the common factor of the x group, which is 1, multiplied to the last term of the trinomial, which is 1, plus the common factor of the y group, which is 4, and then multiply to the 16 here, which is the last term of the trinomial. And then step 5, you have to simplify the equation. To simplify, that is 1 times 1, that is 1. 4 times 16, that is plus 64. Then negative 61 plus 1 plus 64 is 4. This is the new equation. For step 6, you have to express the perfect square trinomials into square of binomials. To express that, all you need to do is get the first degree of the x, that is x, plus copy the 1 since it is just a 1, and then square that. And then for this side, you have to get the first degree of the y, that is y here, and then get the square root of 16, that is 4, and then square that. This is the new equation. For step 7, you have to divide the whole equation into its constant term, which is 4. Dividing that is 4 divided by 1 over 4 here at the denominator, and then the square of the binomial is at the numerator. Then 4 divided by 4, that is 1 at the denominator here, and then the square of the binomial at the numerator. Then 4 divided by 4, that is 1. Therefore, the final answer is x plus 1 squared over 4 plus y plus 4 squared over 1 equals 1. So that is all for the transformation of the equations of an ellipse from general form to standard form.